Sure. So if anyone has any questions, feel free to ask away on the mic or type them in the Q&A or the chat. We have about 5 to 7 minutes, so we have some time.
Yeah. All right. I have a question for the last speaker. So what is the primary difference between the HVM cubed versus M cubed? Is it beyond size?
For Lunar Trailblazers, HVM cubed versus M cubed. Yeah, so sorry, the slides, we're going by fast. I don't know if it's possible to bring up the instrument slide back up, but the basic differences are that HVM cubed provides enhanced spectral range, whereas M cubed cut off at 3 micrometers, which is sort of the start of the absorption feature that allows us to discriminate water versus ice. Lunar Trailblazers HVM cubed goes out to 3.6 micrometers. You could go back 2 slides. So that enhanced, sorry, one more. That enhanced spectral range that you see there of 0.6 to 3.6 will enable capturing the full feature, allowing that H2O ice versus bound water discrimination, right? Mineral bound water. The spectral resolution is higher. It's 10 nanometers in that spectral region as opposed to 20, which goes to the discrimination. The spatial resolution is about a factor of 3 better. And then the signal to noise we're anticipating is at least a factor of 10 better, which will allow us to get the high spatial resolution in the permanently shadowed regions. So it's really optimized, as I mentioned, for water, ice versus bound H2O discrimination, and the requirements are driven by the low light PSRs.
Great, thank you. It's a very improved version.
Yeah.
Thank you.
So we have a question from Kesha Rogers. The question is, can you speak more about the near infrared lasers the lunar flashlight will use?
Yeah, this is Paul Haynes. So they are semiconductor diode lasers, quasi-continuous, and they're supplied by a company called Delis.
Hey, great, thanks. So you still have time for 2, 3 more questions if anyone wants to chime in.
Well, this is Bethany Ellman. I'll ask Paul Hayne a question if there isn't another question.
Sure.
Paul, great. Thanks for presenting Lunar Flashlight. With Lunar Flashlight, what do you anticipate the sensitivity is on either a per weight or a per area basis within the footprint, which I think you said was maybe a kilometer? Can you talk a little bit about detection limits?
Yeah, so our target is 0.5 weight% within that integration distance, and our requirement is 1%. So 1% is what we expect to achieve. And that's again, weight % of water ice relative to regolith.